All right, welcome. This is the fourth talk of the morning session, day 3 of the iRODS User Group Meeting 2020. We've got our friends from Bristol Myers Squibb. This is Mohammad, Shaikh, and Oleg Moiseyenko, and they're going to talk about all the things that they're working on with iRODS at BMS, including the work with Amazon. Go for it, Mohammad.
Okay. So good morning. I'm happy to be here. Bristol Myers is a biopharma. We discover and develop innovative medicines in oncology, fibrosis, cardiology, and recently we acquired Celgene. So we are also into cell therapy. So we've been using iRODS since 2017, and we have applied iRODS from early drug discovery phase to preclinical. So today we'll be talking about a few of our use cases, applications, the challenges that we have been facing. And we will also talk about how we extended the use of iRODS to for machine learning and data lakes. So that's a couple of topics we didn't talk about in previous conferences, so we'll highlight that as well. So next slide, this is all about big data, right? So our data has been exploding over the last few years, right? We are in tens of petabytes, right? So iRODS is over the last 2 years, we are about 20 to 30% of our coverage of managing our data sets in iRODS, so a long way to go. The source of our data sets is mostly through lab, clinical data, patient data from many sources, including universities. And we have been getting data from Sanger, right? The previous speaker talked about, and we felt a little closeness to the data sets there as well. We get lots of data sets from Broad Institute as well. So we have applied iRODS in our workflows for next-gen sequencing, for flow cytometry, and for imaging, right? So the other use cases we're still embarking on. Next-gen sequencing was our first use case, our largest data set. Flow cytometry was more at a cellular data analytics using machine learning. And image data set was more about managing high content screening. So that, so what are the lab challenges, right? So data coming from the lab have different structures, different file types, and the lab workflows are also different, right? So variability of the data and just the speed at which we need to look at the data is very high. So those are the challenges. Moving the data to cloud is a big challenge. So networking and storage and compute power plays a big part. And then we have the requirements for testing and validating the data before we actually move into our repositories, before we move it into AWS and ingest into iRODS, right? And then once we have the data catalog, we expose the data to our applications, mostly data mining applications, right? And then we have to maintain the data standards that are imposed on us, right? So those are some of the challenges within which, and iRODS has been very instrumental in bringing our data analytics to the next stage, right? So we have only been using about 2 years now, but we have made good progress in some of the areas. So a typical data flow looks like this, right? So we get data from scientific instruments, right? We move the data to AWS through a variety of methods, right? So data that requires validation at the source, we use AWS storage appliances, right? They have a good cache and drives the data to cloud asynchronously. We use services like data sync, CLI, We have tried Snowball as well for big data sets, ingesting that way as well. And we have a 10G pipe to AWS with direct connect. So we keep the pipe very busy. So once the data lands in S3, iRODS scans the S3 bucket regularly, right? And the application will query the ICAT and using iSQL and many other APIs to query the iRODS metadata catalog and find and search the data sets. The base iRODS architecture is, BMS is a global company, right? So we have our R&D environments at multiple locations. So primarily, we have just started using it in US area only. So East Coast and West Coast are the sources of data for us. We use metadata catalog to expose the metadata to many of our applications, right? We use rules engine for logistics purpose. We use iRODS as a component of moving the data out of BMS to our vendors, right, and bringing it back as well, right? So we'll go over some of the use cases on how we do it at a high level, identify some of the challenges. Then Oleg will follow up on how Oleg has worked with Terrell to solve some of the problems that we are facing. So here's genomics is where we started, right? So we get the data from our sequencers into NetApp, right? That's our data collection or data capture on-prem, and then move it to cloud. So this slide just gives you a gist of what we are using in terms of scale at the consumer worker level, and what server sizes are there for each of those components. We use 2 zones, right, for redundancy. And so today we have about 50% of our sequence data catalog. We are still a lot of way to go, and we'll dig a little deeper into some of the challenges of the data flow and what role iRODS plays into. So here's a little bit deeper view where we process the data internally as well as externally, right? So naturally, for whole genome sequence analysis, we send the data to 7 bridges. We do variant calls using base space. So there are multiple external vendors involved as well. So a lot of code written in Python as well as AWS Lambda to move the data around. So here's another data type. This is high content screening. High content screening is more on fluorescent analysis, or and the data set for this is an imaging data sets coming from a variety of scientific instruments. So a lot of different data types. So tagging is important here. And some of the tags we ingest into the catalog as well, right? Many of the tags sit as tags on S3 and also in our vendor databases. So iRODS metadata catalog will interact with image analysis tool, internally developed and also third-party tools. So it is a central piece of how we move data around. Let me just build it. So flow cytometry is another example for using iRODS. Here we are using iRODS as a pipeline for experimental design, analysis, and also visualization tools like Spotfire. So iRODS is a central piece where these different applications would query the data and find out where the data is. We manage the workflow right from after the raw data capture into moving into data lakes, right? And you can see the number of third-party applications that use this data sets. So with flow cytometry, the data ends up in data lakes, right? And there are two things that we had to interface iRODS with. We use Informatica-based data lakes, and we use machine learning algorithms. Some are developed just for us. Some are more open source, like Disney. Right, so here's what it looks. I know it is very deep, but I just wanted to give a flavor of what it takes to put this solution together. And when we use a tool like iROD to manage the data between different workflows, different tools, especially newer technologies for us for ML, it takes a lot outside of iRODS as well to make this work, right? So in this use case, we use unsupervised analysis pipeline. So flow cytometry data is data at a cellular level. So each sample would have somewhere around 45 to 50 million events. So we cannot tag the data, nor can we annotate it, right? It is just too big to do that. Therefore, we use unsupervised learning in there. iRODS is central to the pipeline, right? We are building several pipelines like this. Flow cytometry is just one of them. So here is something that we debated for some time on what is the overlap between iRODS and our internal data lake, right? So we ended up, after many of our architectural discussions, debates, we said iRODS would be a system of record, right? So it will be the source of knowledge for our metadata, and then data lake would serve as a system of insights. So there are a few things that iRODS does better, and there are things that data lakes has features that iRODS doesn't. So here's just a quick table of only a few things that we are really critical, right? So moving data from our premises to cloud and managing the data, naturally we do it with iRODS. Data lake doesn't have this feature, right? So technical metadata, iRODS become the source of truth for us. And it is also replicated at a very smaller scale for the sake of efficiency into data lakes as well. So business metadata, naturally the source becomes iRODS. And for insights, the data lake serves as the enterprise repository of knowledge, right? So today the data acquisition part is fully covered by iRODS, while the analytics side is covered by data lakes. So there are some of the hooks that we needed to build between iRODS and our data lake. So a lot of challenges, some of the code done by Oleg and his team. So he will cover that as well. Oleg, is this where I transfer to you?
Yes, Mohammed.
All right, take it away.
Thank you. Let me share my screen. Mohammed, can you stop sharing, please?
Sure.
Thank you. Can you see my slide? Okay. Thank you, Mohammed, again. Thank you, Terrell, and thanks everyone for having us on this conference. Really excited to be here. I'm Oleg Moiseyenko, Associate Director of Scientific Computing Systems at BMS. And we continue our presentation about how Bristol Myers Squibb use iRODS. And for starting, I just present initially this slide to show you roadmap. Our company completed in iRODS participation. I still consider iRODS pretty young platform at Bristol Myers Squibb. As you could see, we pretty much just 2.5 years on a road with iRODS, but still we already accomplished very challenging projects using iRODS for computational genomics team at BMS. Currently, another major project for enterprise collaborative labs and discovery imaging platform as work in progress. And we have a new project for flow cytometry in a pipeline coming up. And of course, this is not end of story, because our ultimate goal is moving gradually towards iRODS data farm. And this is how we envision this on a high level, since my company has a wide footprint, not only along the United States, but along the globe. We want every department use iRODS, and we plan to divide this in different zones and use iRODS to build a global search index on top of these data sets. And when through iRODS data farm, we plan to organize data sharing between various groups, and of course, multiple applications Bristol Myers Squibb currently use for our pipelines. Also, we'll be using a wet iRODS Global Search Index for data discoveries, data mining, and data access. And just to put this in perspective, I want to say a few words about data, scales of data sets we currently use. Keep in mind that these slides just talk about a single iRODS naming zone, since we already have several zones. So one of our biggest zones currently has 200 plus S3 buckets. I want to say that we are a cloud-centric company, and pretty much 90% of our data currently resides in AWS cloud. So, and in total, within this zone, we already registered more than 800 million different objects, and I think very soon we will come to 1 billion. And the total data sets per this zone only is exceeding 10 petabytes already, and it's growing really, really fast. So I think in next 3-4 years, it would double that. And as of now, we use daily jobs to scan and register new objects, and we use multiple worker nodes to do this job for us, and the speed is really decent. We're capable to scan around 5 million of new objects per hour. I would say that iRODS is very, very effective in scanning of S3 storage space. And of course, along this road, we tried and we successfully used multiple plugins and features in iRODS. Specifically, S3 plugins has daily use in BMS. And again, we host all iRODS services in EC2 instances on Amazon AWS. We like and interested in future developments of NFS RODS plugin. We use metalinks to provide a convenient graphical user interface to our scientists to search through this data. And iRODS meta catalog built with AWS RDS PostgreSQL database, and we also use trigram indexes, which have been introduced just recently. And thanks to this feature, our search for iRODS catalog database become much faster. And when we recently started using a new functionality for us, there was Lambda functions over SSL. And this is where I want to continue my conversation a bit more technical, because it's a really interesting feature. First of all, iRODS data ingest, traditional way how we do this before, and we're still doing that for a few projects. We engage iRODS daily data ingest jobs, which scans on a daily basis through a lot of S3 buckets, and we ingest new S3 buckets, new S3 objects from multiple buckets in the iRODS metadata catalog. It works really well. We tested this with multiple projects, and it's a wonderful solution, no complaints, but still it has some limitations. For instance, as you could understand, the iRODS catalog is always behind, since we have so many buckets, and some of these buckets are petabytes at petabyte scale. So scanning through such a big S3 object store space requires some time. And the second issue we observing is negative space, deleted files. For instance, our applications quite often could interact with S3 buckets directly, not through iRODS. And if some changes happened because of these applications on S3 level, when iRODS become not aware of these changes, and this could cause significant problems in future during our data pipelines. So in order to overcome this, we suggested such new architecture around Amazon, built around Amazon Lambda function. And iRODS consortium and Terrell especially have been very useful to help us organize and implement this. So in a nutshell, raw data from BMS data labs come to Amazon S3 bucket. And upon completion of data uploading to Amazon S3 buckets, what could be done through different methods, this triggers new events on S3 level. And these events transfer to SQS through subscription to Amazon SNS topics. And when new messages in Amazon SQS queue triggers a Lambda function. And these Lambda functions register new objects within iRODS metadata catalog. And of course, same Lambda functions could be triggered upon deletion of data from Amazon S3. And that way, iRODS become nearly lifetime system, what is very significant improvements for us. And of course, since we have multiple S3 buckets, we were able to develop Lambda functions and architecture what works with through a lot of S3 buckets. And these have been already tested in our development environment. It looks great, and keep in mind that Lambda functions works with SSL support, some additional parameters and variables Lambda functions used kept within Amazon Systems Manager. And we also use Amazon CloudWatch to monitor this solution and sends any alerts. This works really well, and we currently about to start uploading this to our production environment. Of course, since we have so many buckets, we will do this in few stages, but hopefully upon our next UGM forum, I would able to report results of this new project. And my next slides just represents a few additional technical details we currently use with this AWS Lambda function. The interesting thing about this is it was developed within Python 3.7. And since we use SQS, we currently our queues configured with batch size equal 1. What it means that Lambda functions triggers every time when new object arrived to S3 storage space. It works great, but we see some potential for cost optimization, and probably in future we would try to improve this and change batch size to 10, and this way Lambda functions will trigger in batches every time when 10 new messages arrived to S3. This is just a way for improvements for future. And of course, these Lambda functions use systems manager parameter store, what is very convenient for us, very convenient place for us to keep our secrets. It has a built-in SSL support. Link to a GitHub repository is given below, and it's a very fresh solution. As you could see, it's basically was released 1 month ago, and we're really excited about this because it makes our iRODS platform near real time, what is very valuable feature for my company. And last but not least, I want to say thank you to BMS Cloud and SCS teams, and say thank you to our main iRODS administrator, Dmitry Khavich. Of course, iRODS and Rensi, specifically Terrell and Jason Kaposki, helps us a lot in this developing this solution. And now I think Mohammad and I will be ready to take any questions.
Very good. Thank you, both of you. It's great. It's wonderful to see. That's a lot of things going on in those slides. It's very complex architecture. Mohammad, to that point, you talked about other cores kind of coming online soon. Are those architectures probably going to look the same? Is this a standard in any way now? Is this something that other groups are looking to you to show them how it's done?
Yeah, so after the first 3 applications, a pattern is emerging. So we have been discussing with our enterprise architecture team to come up with a standard framework, a standard architecture. We are not there yet. So I think we still need to do a few more to see if how things change, because the business units are different. Scientists have their own way of doing things, right? And then there is a lot of influence from open source community as well, right? So we want to make sure that not just we have a standard framework, but we are agile enough to adopt new things as they come.
Is there any place for conversation between different pharmaceutical companies on this kind of thing, or is it mostly secrets all the way up and down?
No, I think we, Oleg and I are part of the early drug discovery program, and we are very open with our colleagues, right, in our peer industry. We do participate in HPC Cross Pharma Forum. So we have other pharmas like us, and we have talked about our use cases at that forum. We have presented naturally in AWS reInvent. We were scheduled to do one at BioIT World in April.
Of course, yes.
It will be in October. So we will share this. We occasionally talk with our colleagues at Merck and others, right? Pfizer is there, Novartis is there. So they, I think some of these companies have dabbled with iRODS before us, so they have their own experiences also.
Certainly. I do have a couple questions. One from our friend John Constable at Sanger. He says, the cloud is famously expensive for data at rest and egress of the same. How are you managing the cost side of this? And you answer this a little bit by saying that 90% of your data is there, so maybe it's not leaving as often as John is thinking it is. Are there any other clever rules that are managing the data flow to reduce cost or to optimize the cost?
Terrell, of course, and John, of course, yes, all S3 operations, data transfer incur some charges from Amazon, but we trying to use as much as we could lifecycle rules. So if data not been accessed for a while, we move this data to a special storage tier called infrequent access. And we found very effective algorithm provided by AWS Amazon called intelligent access tier. And they use machine learning algorithms to move data from active access to inactive access. And it helps us save a lot.
Very good. And I think you may have answered this on the last couple slides, but John would also like to know, what is the size of your iRODS team? Is it the 2 of you? Is it the 3 of you? And then he's got another couple questions about the versions of iRODS.
I guess Mohammad could answer this question.
So no, our team is currently small, who are 100% dedicated. Like Oleg has his team. Primarily, we have one iRODS administrator, Dima Kavish, who's managing all the configuration aspect of it. We do have developers that work on a project level. So they are not 100% on iRODS. They just use iRODS and solve problems that are specific to their workflow. So we have, I would say around a team of 5 or 6. And
then his other follow-up was, how do you plan for your upgrades? Earlier there was a talk about how Sanger has spent many moons and lots of coin trying to figure out how to upgrade cleanly. And so how do you do that?
Yeah, it's an interesting question. Thank you. In fact, it's a little easy for us since the foundation of our architecture is S3 and no actual data movements required. So the planning for upgrades is quite easy for us. At the time of upgrade, we just shut down all our iRODS services. We do software upgrade on them, we do a database upgrade, and we start it up. But of course, everything needs to be tested carefully first in our development environment. But again, since no actual data movements involved, and this is one of the benefits of cloud architecture, it's pretty much painless to us.
It's good to hear. Excellent. Nirav at Arizona has a question. Are you using caching for edge data delivery?
Yes. Terrell, am I right? We use S3 caching.
I don't know what your S3
I'm trying to understand exactly what S3 caching means.
Well, edge, sorry.
Yes, we do. Yeah. Let me jump in. We have AWS's gateway appliances in 2 of our locations.
Oh, I see.
Yeah. So and they provide, I think, an effective cache of 13 terabytes.
I see.
So it does make iRODS look like it is real time, but behind the screen it is asynchronous. There is a delay. Mm-hmm. Right, but for those local cache, and they are primarily used in use cases where we require data validation. So if they need to repeat the experiment, repeat the run, they just cancel and then rerun it.
Right.
Or we move.
Similar last question from Raja. He's do you have any integrity checks on the data through any policies? Checks.
It's difficult. We wish to have checksums everywhere, but of course, when you have so many objects, as I mentioned, we very close to 1 billion objects within a single iROD zone. It would take forever to produce checksums on these objects. So right now we just rely on data names, on file names, on timestamps and data sizes. It's not the best probably approach, but the only doable available option for us now.
Very good. I think we are. Anybody else have any questions? Anyone would like to raise their hand and ask something of our two guest speakers here? Dima has given us the strong arm emoji in the chat.
Thank you, Dima, for your support.
So Terrell, before we close, I don't know if AWS is part of this conference and they are listening, but we all influence each other's opinion, and I would like to take the opportunity to push a little bit from our side, if they are listening, that we are waiting for AWS outposts. If there is S3 at our locally, and we have iRODS on top of it, that would be great.
So it's S3 on premise, basically.
Yes. Yeah.
Right. I will pass that along. Thank you so much, both of you, and hope you have a great day and watch the rest of these presentations. Appreciate it.
All right.
Thank you, everyone.
Bye-bye.